Good morning, dear students. I'm here again with part 4 of chapter 10, that is gravitation. Okay, so what we are going to learn today? We are going to learn very interesting and very important topics in this session. Let me show what are these topics. The first topic will be thrust and pressure, and then we'll learn about the pressure in fluids. The next one will be buoyancy, and then we'll discuss why objects float or they sink when they are placed on the surface of the water. Okay, so let me start. So let me start with my first topic, that is thrust and pressure. Before introducing thrust and pressure to you, let me put some interesting facts before you. Those facts will be very much helpful to us to understand these two important physical quantities. You know that camels can run in a desert easily. On the other hand, for us, this activity is not easy. We cannot run in a desert easily. On the other hand, camels can do this very easily. An army tank, that is very heavy one, that has thousands ton of weight, it can rest upon a continuous chain. Easily it can rest. Okay, see here you can see that is a continuous chain and this tank can rest on it. When we have to cut the fruits or vegetable, we use a knife having sharp edges. A truck or motorbike, they have wider tires. All these facts are very much helpful to us when we are going to learn about the concept of thrust and pressure. These facts help us to introduce the concepts of net force in a particular direction or the net force per unit area. Okay, these two are the quantities that I'm trying to introduce to you. Net force in a particular direction is called thrust, while the net force per unit area is called pressure. Okay. To explain the thrust and pressure, we'll take help of these two situations. Here is the situation one. Very common activity it is when you have to fix a poster on a bulletin board. What do you do? See, simply you just press the drawing pins with your thumb. Okay, here also the boy is doing same thing. In the picture you can see this is the drawing board. Just follow the marker. See, this is the board, bulletin board, and here is the pin. And this boy is just trying to press the pin. Okay, see, when we have to fix the poster on a bulletin board, we just press the drawing pins with our thumb. Okay, have you noticed that we are applying a force on the surface of the area of the pin here? Okay, on this small area we are applying a force, and this force is directed perpendicular to the surface area of the board. See, that is board and that is the direction of the force applied. And the whole force is applied on this small area of drawing pin. Okay, on the tip of the pin we are applying a force. It is more clear in this picture. Here is situation 2. When you stand on a loose sand, your feet go deep into the sand. But on the other hand, if you lie down on the sand, you will find that your body will not go that much deep into the sand. In both the cases, force exerted on the sand is the weight of your body. Here also, the force exerted on the sand is your body weight, and here also it is on your body weight. Then why it is happening that in this case situation, when you are standing on the sand, then you go deeper, but while you are lying over here, you do not go that much deeper. The reason I'll explain in next slide. See, When you stand on the loose sand, what happens? The force. The force is acting on the area equal to the area of your feet. The total force of your body is acting on this much area. Okay. See, look at the marker carefully and you will understand the concept clearly. When you are standing on the loose sand, the total force of your body, that is the weight of your body, will act upon this area. But on the other hand, when you lie down, the same force of your body, okay, that will act upon a bigger area. At this time, when you are lying down, the area has become more. The force is same, but the area is increased. So the area of your body when you are lying down on the sand is larger than the area of your feet. Thus, the effects of the force of same magnitude on the different areas are different. Very important line. What did you get? See, let me make it more clear. The force that is acting on the sand is equal. Why? Because both the times when you are standing or you are lying down, it is the force of your body. But when you are standing, the area is less. And when you are lying on the sand, the area is more. So the magnitude of the force is same, but it is directed towards different areas. So in the above cases, thrust is same, but the effects of this thrust are different. Therefore, the effect of thrust depends on the area on which it acts. The effect of thrust on the sand is larger while standing than while lying. That is why you go deeper and deeper when you are standing on the sand. Okay? Thrust and pressure, both are the force. But then what is the difference between them? Okay, let me show you what is the difference between both the quantities. Uh, to explain that, let me recall what is weight. The weight of an object is the force acting on the object due to gravity. Okay, the unit of weight is Newton and it is a vector quantity. Thrust is a reaction force that is described or defined by Newton's third law. Thrust is also a vector quantity and unit of thrust is also Newton. Why? Because thrust and weight both are force. So that is why they are having the same unit, that is Newton. Let me tell you one more time what is the difference between weight and thrust. See, both are force. That is the similarity. But the weight is the force acting on the object due to gravity, while the thrust is a reaction force. Okay. Now, when thrust is applied on unit area, it is called pressure. This is the definition of pressure, and let me show you the formula to find out the pressure. Pressure is equal to thrust upon area, and the unit of pressure is Newton per meter square. Means at unit area, the amount of the thrust is called pressure. And in honor of scientist Pascal, the SI unit of pressure is called Pascal also, and that is denoted by PA, that is Pascal. Here is the example from your textbook, example 10.6. Let me read the example for you. Okay, you also read with me so you will understand it clearly. The example is a block of wood is kept on a tabletop. The mass of wooden block is 5 kilogram and its diameters are 40 centimeter, 20 centimeter and 10 centimeter. Means the height of the block is 40 and one side is 20 centimeter. Another side of wooden block is 10 centimeter. Okay. So now you have to find out the pressure exerted by the wooden block on the tabletop if it is made to lie on the tabletop with its sides of dimensions. Okay, the condition A is 20, 10 and condition B is 40, and 20. Fine. So this wooden block is kept on the table. Okay, and these are two types. At first it is kept like that, and in second condition it is kept on the table like that. Now we have to find out the pressure. Okay, so at first I'll solve and find out the pressure for first condition. This is the first condition, condition A, and this wooden block is kept on the table like this. The mass of the wooden block is 5 kg, that is given in the numerical itself, and the dimensions are 40 into 20 into 10. Okay, now the weight of the wooden block applies a thrust on the tabletop, that you know. So what is thrust? Thrust means the force that is applied on the surface. So we will find out the thrust by F is equal to mg. And what is the mass of the block? That is 5 kg. What is the value of g? It is 9.8 meter per second square. And after multiplying these both the values, we get 49 Newton. So now we have thrust. What is the area of the site? Area will be 20 multiplied by 10. So that is 200 centimeter square. And if we change centimeter into meter, we will get 0.02 meter square. Fine. We have to find out pressure. What is the formula to find out the pressure? The formula to find out the pressure is thrust upon area. And here you are having the value of thrust and area. Now you just have to substitute these two values in the formula and you will get your answer. So pressure is equal to 49 upon 0.02 and we'll get the answer. This is 2450 Newton per meter square. Now we'll move towards the second situation. Okay. In second condition, the box is kept on the table like this, as you can see on the in the picture. Again, we will find out the thrust. Thrust is F is equal to mg and it is 49 Newton. Area, and this time area will be different. Why? Because it is kept horizontally. So area will be 20 multiplied by 40 and it is 800 centimeter square. Now we'll convert it into meter square and we'll get 0.08 meter square. Now use the formula to find out the pressure. Pressure is equal to thrust upon area. 49 upon 0.08 and we will get 612.5 Newton per meter square. Okay, so the pressure exerted by the side 20 into 10 was 2450 and by the side 40 into 20 is 612.95 Newton per meter square. So what did you see? You saw that the same force acting on a smaller area exerts a larger pressure and a smaller pressure on a larger area. This was clear when we solved this example. This is the reason why a nail has a pointed tip, knives have sharp edges, and buildings have wide foundations. Now we'll discuss pressures in fluid. All the liquids and gases are fluid. They can flow, that is why they are fluid. A solid exerts pressure on a surface due to its weight. See, fluids have weight, okay? And they also exert pressure on the base and walls of the container in which they are enclosed. No matter what is the shape of the container, but they will apply a pressure on all the sides. Pressure exerted in any confined mass of fluid is transmitted undiminished in all the direction. Here in picture you can see that this liquid is applying pressure in all the directions and the shape of the container is circular. So in all the direction it is applying a pressure. Buoyancy, that is the next physical quantity that I need to introduce here in this chapter. Before defining buoyancy to you, let me put some interesting facts that you have noticed. When you swim in a pool, you feel you have become lighter. When you draw water from a well, you feel that the bucket of water is heavier when it is out of the water. But when it was inside the water, it was lighter. So when things are inside the water or inside the liquid, we feel that they are lighter. Have you ever wondered why a ship made of iron and steel does not sink in seawater? But on the other hand, same amount of iron and steel in the form of sheet or ball would sink down. If you try to find out the answer of these questions, you will get to know about buoyancy. Without taking buoyancy in consideration, we cannot answer these questions. So now let me tell you what is buoyancy. Here is the activity in your textbook to explain the buoyancy and buoyant force. What is the activity? Activity is very simple and very interesting. So let me explain this activity to you. You just have to take an empty plastic bottle and close the mouth of the bottle with an airtight stopper so that air cannot enter the bottle. Okay. Now put the bottle inside a bucket that is filled with water. What do you see? You see that bottle floats. Now you just try to push the bottle downwards. What do you observe? You feel an upward push. You try to push it further and you will feel an upward push. Okay. The upward force exerted by the water goes on increasing as the bottle is pushed deeper. Now do one thing, release the bottle. What do you observe? You observe that bottle bounces back to the surface. So what is this force by which the bottle is coming in upward direction? Is it a gravitational force? No, it is not the gravitational force applied by the earth. It is a force applied by the liquid in upward direction. Okay, and that is buoyant force. So I think after this activity, it is clear what is buoyant force. The force applied by a liquid on any object in upward direction is known as buoyant force, and this property of the liquid is known as buoyancy. Fine. So the force due to the gravitational attraction of the earth acts on the bottle in downward direction. That is why the bottle is pulled downwards, but the water exerts an upward force on the bottle and the bottle is pushed upward. So we know that the weight of the object is the force due to the gravitational attraction of the earth. So when the bottle is immersed, the upward force exerted by the water on the bottle is greater than its weight, then only it will come upwards. If this force is not greater than the weight, the bottle will not come upward. To keep the bottle completely immersed, the upward force on the bottle due to the water must be balanced. This can be achieved by an externally applied force acting downwards. This force must at least be equal to the difference between the upward force and the weight of the bottle. See, if you look at this picture, you will understand the concept clearly. That is the object. If it is placed inside the water, what will happen? See, the weight of the object will act downwards and buoyant force will act in upward direction. Okay, here buoyant force is greater than the weight. So the object will float. On the other hand, what do you see with this yellow color ball? Here you see the weight is greater than the buoyant force. So the object will sink. Now here is the definition of buoyant force. The upward force exerted by the liquid on the object is known as thrust or buoyant force. Okay, this is the definition. See, all the objects experience a force of buoyancy when they are immersed in fluid. The magnitude of this buoyant force is not same for all the liquids. It depends on the density of the fluid. Now the question is why objects float or they sink when placed on surface of water. For that we'll do an activity. You have to take a beaker and fill this beaker with water. Here is a beaker filled with water. Now take an iron nail and place it on the surface of the water. What do you observe? Here is the nail. You can see that nail goes inside the water and it sinks. Fine. This is your observation. You can do it at your home also, and you can send me the videos. I think observation will be same for each and everyone, and the observation will be the nail sinks. The force due to the gravitational attraction of the earth on the iron nail pulls it downwards. There is an upward thrust of the water on the nail which pushes it upwards. Both the side it is feeling an force. In this direction it is feeling a gravitational attraction, but in upward direction it is feeling an buoyant force. Now the downward force acting on the nail is greater than the upward force, and that is why the nail sinks. Very much clear it is. Here is another activity. Again you have to take a beaker and fill this beaker with water. Now this time you have to take a piece of cork over here. This is the piece of cork. Here you can see the piece of cork. Okay, and now place this piece of cork on the surface of water. Now this time what do you observe? At the time of the nail, you observe that the nail sinks. But when you try the same activity with the cork, what do you observe? The cork floats while the nail sinks. Why does this happen? This happens because of the difference in their densities. The density of both the objects are different. Let me first define what is the density. The density of the substance is the mass of the object or substance per unit volume. To find out the density, we will use the formula D is equal to m upon V, where m is equal to mass of the object and V is equal to volume. And unit of density is kilogram per meter cube. The density of the cork is less than the density of water. What does it mean? It means that the upward thrust of the water on the cork is greater than the weight of the cork, and that is why the cork floats. See, here is the cork, and the weight of the cork is in this direction, while the upward thrust in this direction. Okay, the upward thrust is more. That is why cork is floating. On the other hand, the density of an iron nail is more than the density of water. It means the upward thrust of water on the iron nail is less than the weight of the nail, and that is why iron nail sinks. See, this is iron nail. This is iron nail, and here in upward direction, buoyant force is there, and weight of this nail will be in downward direction. Okay, but the weight will be more and buoyant force will be less. That is why this nail sinks. So now I think it is clear to you why the cork floats and iron nail sinks. So, on the basis of the observation, we can say that the objects of density less than that of the liquid float on the liquid, while the objects of density greater than that of the liquid sink in the liquid. So, density of the object is lesser than the density of the liquid, object will float. Density of the object is greater than the density of the liquid, the object will sink. Now here are some questions. Let me read the questions and answer for you. The first question is, why is it difficult to hold a school bag having a strap made of thin and strong string? Okay. So here is the answer of that. It is very difficult to carry a bag having a skinny strap. Why? Because of the pressure on the shoulders. This can be as the result of the pressure is reciprocally proportional. Reciprocally means opposite to the expense on that of the force acts. The smaller the surface area, the larger is the pressure. Within the cause of the skinny strip, this happens. The contact expense is extremely small. Hence, the pressure exerted on the shoulder is extremely huge, and that is why it is difficult to hold a school bag having a strap made of a thin and strong string. Okay, if the straps are broad, it is easier to carry the school bag. The second question is, what do you mean by buoyancy? In the same session we have discussed in previous slides, then also let me answer it for you. The upward force possessed by a liquid on an object that is immersed in it is referred to as buoyancy. The next question is, why does an object float or sink when placed on the surface of water? And here is the answer. If the density of the object is lesser than the density of the liquid, the object will float. And if the density of the object is greater than the density of the liquid, then the object will sink. So, okay, students, this much was there in this session. I hope you liked the session. You can go through the session again if you have some doubts. Your today's work is write down the question answer in your fair book and learn. Now we'll meet in part 5. Till then, you review the session again. Thank you.